and share my screen. Yes. Okay. So during our classes, we use a lot of corpora, as my students already know. We start in lexicology classes when we use ready-made corpora. But in terminology classes, students compile their own corpus on their own. They choose a domain they are interested in, either it's their hobby or an area which they maybe wanted to study as well. Let's say one of my students wanted to study either biology or philology and ended up in philology, but she was very interested in biology and her terminology project was on biology. I had students who were sportsmen, tennis, football, and they did their terminology projects on these areas. So each student can choose a domain which he or she is interested in and work on it. The aim is to compile a corpus, extract terminology, definitions, and compile a term base. Students who got very interested in, they can continue this project for their term paper and bachelor paper. So Katerina, who is unfortunately sick and cannot present herself today, she has chosen the domain of cyberbullying, actually. She started with the terminology course and continued until her bachelor defense. So we called our presentation with Ekaterina, how can a corpus help in a study of specialized domain and its terminology, as this conference is namely how technologies can help in developing language skills. So the aim is to present the application of corpus linguistics methodology in exploration of a specialized domain and its terminology, and it is exemplified with the cyberbullying domain. Now the stages, so first of all, it is compilation of a corpus, and we use the sketch engine software and platform for our research. Then it is extraction of terminology using various tools, then extraction of definitions. Actually, if a corpus is well compiled very carefully, you can find a lot of definitions in it as well. One more objectives which Ekaterina pursued was extraction of verbal collocations. As verbal collocations and sentences also tell a lot about the domain and what is happening in it. So now the scope of the data set. Corpus we call input data. So Yekaterina was very diligent. She selected, as you see, 205 documents. All of them are scientific articles on cyberbullying, and it is quite a big corpus, actually, 2 million words. For self-compiled corpus, it's quite quite a lot. As you see, she extracted 100 terms, actually much more, but she selected manually 100 terms for her analysis, and then 42 definitions she managed to find in her corpus. So now about every stage. So the first stage is compilation of the corpus. starts with the search of texts using Google Scholar and Sketch Engine. So actually, Yekaterina used both Google Scholar and searched in it, but Sketch Engine also has, you remember very well, that automatic tool when you enter keywords, yes, and it searches on articles online itself. Then collecting and systematizing metadata is a huge work to collect all metadata, but it's very important because then you can use that corpus in a much more sophisticated way. Uploading all text and metadata to Sketch Engine, and Sketch Engine then pre-processes them. So here, how metadata looks in Sketch Engine, you enter certain categories of metadata. Here they are called attributes, and then values, so actual information. In Excel file, they look like that. As you see, Ekaterina collected all titles, authors, publishing year, run. She also indicated whether the scientific article was found by Sketch Engine, then Webboot tool, or by Google Scholar. Now, next stage, when you have a corpus, you are satisfied with it, you start with the extraction of terms. Again, using Sketch Engine, Yekaterina used two tools, mainly keywords, which we haven't used yet in lexicology, and WordSketch, which you know very well. So extracted first of all automatically, and then selected them manually and systematized them according to their semantic groups. So here you see lists extracted by keywords. Now I would like to explain how this tool works. This tool analyzes your corpus and compares it with another corpus. As you see, the reference corpus is actually English Web 2020. So it compares your corpus with another corpus, which it selects itself. And if a word or a phrase is frequent in your corpus and in that reference corpus, it is not a keyword. But if it is frequent in your corpus, but not that frequent in reference corpus, then it determines that it is a keyword specific for your corpus. So in that way, it determines a list of terms, as you see, single word terms and multi-word terms, and extracts them. Of course, it's automatic extraction. You have to look through it and select what is most suitable. Now, WordSketch. How is WordSketch used? When you have single word terms, so you select the most frequent ones, and then you use WordSketch as we use in lexicology and extract collocations. Let's say here you see collocations of bully, yes, and there are again quite a lot of terms which can be useful. Of course, they have to be selected carefully and assessed, but you get quite a lot of useful and very valuable data. One more tool, of course, you can also use word list, yes, and get most frequent single words. But you know, in terminology, multi-words are most important. There are not so many single words in terminology. Usually, terminology is two or three words long. Okay, so first of all, it is extraction. Then I always ask my students when they do manual selection, think about semantic groups. So first of all, my students explore the domain. Yes, what are participants in that domain? What activities happen in that domain? And when they are selecting terms from these lists, they have to think already. So what semantic groups are important and what terms I have to have in that final list. So here you see at this initial stage, Ekaterina focused on types of bullying and participants. Now, next stage, when a student has terms, a list of terms, it is extraction of definitions. Again, using sketch engine and CQL. Students like CQL a lot. It is corpus querying language. I will show a little bit of it later. Then systematizing definitions, categorizing terms into conceptual categories, and modeling concept system. So CQL, how does it work? CQL, it's like a little bit programming because you inside such commands what sketch engine has to look for. So here you see the command is to look for sentences which include defined as and sketch engine extracts then all sentences which include, in this case they had to include participant, term denoting participant, let's say cyberbully, also defined as. Or another command was to extract all sentences including the names of participants and is a formula is also very typical for definitions. And there are other formulas which are very typical for definitions. And in that way, like data mining way, you just try different formulas, different structures, and you try to extract as many sentences as possible. And then you look through them and select the ones which can be used for definitions. Sometimes you don't have like the whole normal definition, but you can use several sentences and on the basis of them formulate a final definition. So here you see systematization of all terms and their definitions. Now on the basis of definitions, categorization of terms into conceptual categories is performed. Now it's much deeper, yes? If at the beginning it was just preliminary when the terms are extracted, now when you have definitions, you do it much deeper. And in this case, Ekaterina established types of bullying. First of all, participants. Then it was very obvious that the dataset contained causes, which cause cyberbullying, consequences, and control measures. So these categories were established. Now, when you have all conceptual categories, then students try to model concept system. And this is actually like the aim of the terminology project is to model, so what is happening in that domain. And here you see that certain reasons, yes, they cause cyberbullying, but at the same time, cyberbullying also becomes an effect and it causes certain consequences. There are preventive measures which are used to prevent or to help with consequences. So this is like causal structure. What else is important? What's important for Ekaterina? It is participants. And here she tried to systematize that cyberbullying. So it's cyberbullies who give rise to cyberbullying, and cyberbullying affects cyber victims. Cyberbullying is observed by outsiders. Outsiders are very often mentioned in scientific articles, and opposed by defenders of cyber victims. So in this, model, so Ekaterina tried to systematize everything, or the whole knowledge about the domain, which she gained through terminology and through definitions. In addition, going deeper, cyberbullying, we could take a look at participants, because participants were especially important for Ekaterina. You see, she calls it causal agents, those who cause cyberbullying, and you see how many terms are used for them. And these are victims, causal patient. Patient is that who experiences the consequences, cyber victim or target child. And there are always people who are also close to the participants, outsiders and defenders. Now, actually, quite a lot of information was already collected about the domain, yes? And actually, here we stop in terminology course. Students develop then the term base. The term base includes English terms, definitions, examples, and equivalents in 2 more languages. But as Ekaterina developed this project further for her bachelor, she included one more dimension. It is dimension of verbal collocations. So she extracted verbal collocations which include the terms of denoting participants. So as you see, it started with extraction of verbal collocations, their categorization, then extraction of sentences, which include these verbal collocations, and their analysis, and establishing situations. So it's again like modeling information about domain, but now using another type of data, not definitions, but verbal collocations. Here you see the list of collocations which Ekaterina extracted and tried to group them semantically, but as you know, it's very difficult because collocations are quite abstract. So finally, we ended up with extracting sentences. Extracting sentences, then the picture is much clearer. Yes. And as I said, all these sentences were with the participants, about participants, either cyberbullies or cyber victims, or people who are also observe that situation and somehow try to influence it. Ekaterina was very ambitious. She made a syntactic semantic analysis. I would say it's really was very complex. We had a lot of discussions, and somehow to put these sentences into patterns, syntactic patterns, was a very big challenge. But she did it. For me, maybe most important here was this part. Syntactic analysis, yes, but establishing situations which are described by these sentences. And the situations described by these sentences were so some sentences described reasons that cause cyberbullying, and there were sentences about various factors which cause cyberbully to become cyberbully, maybe some anger or some other aim of cyberbullies activities. Sometimes, you know, there were a lot of sentences where like victim is described, and that namely characteristics of that victim like becomes a reason for cyberbullying, at least in cyberbullies understanding. And characteristics also, of course, of cyberbully itself. Actually, a lot of material for psychologists. It was very interesting to go here much deeper about to see that characteristics of cyberbully, of victim, and what causes what and why. What factors become crucial that cyberbullying starts. Then next situation is cyberbullying causes effect. So these were sentences which described what consequences are experienced by the patient, and yeah, how are they cause these consequences? Again, a lot of sentences about that. Next, means and methods of conducting cyberbullying. It looks like the means is internet, but you can use internet in various ways. You can block a person, you can harass that person. So all methods could be very clearly distinguished using this deep, I know how to say, deep reading method, and taking counteracting measures. So how these people, adults who observe the situation, how they try to help cyberbullying, and how cyber victims they try to help these cyber victims, and cyber victims they also seek help. So establishment of these situations made the picture which we got here, yes, here the picture was quite abstract, I would say. And I was very happy that in addition to this abstract picture, we got much more concrete information how everything happens, how every mechanism works, and that information was really supplemented a lot. So conclusions. So corpus building and analysis technologies, they first of all allow autonomous both language learning and as you know, my students know, for me, research skills are most important. So, of course, language learning as well. You learn language, a lot of terminology and so on, but research skills. And sketch engine tools enable you to mine in the data set from various perspectives and to get information and very, very different. And in that way, really create knowledge. So it contributes to acquiring knowledge on specialized domain, on its conceptual framework, and the use of language in it. And also has a lot of added values. We really believe, Yekaterina, and I agree with her, that her work could be interesting for psychologists. teachers, parents who would like to understand better the processes taking place within cyberbullying and somehow to combat this phenomenon. So that's it. Thank you for listening. Thank you, dear students. And now I'm giving the floor to my colleagues from Nicholas Romeris University and Vilnius Business College. Yes, so representative of this team will be Darius Valūnas, and the presentation is on errors in machine translation, accuracy versus productivity. So please, the floor is yours.
I'll try to get this flash probably works now. If you just give me a minute. Okay, this one's empty. Yep. Ah, got it. Good. Now need the button, another button. Like this. Okay, hope it works. Yeah, so I just wanted to share a couple of ideas about machine translation and about how I can't see you. About how effective it is and what problems might arise for the consumer if they rely 100% on the machine translation. Well, I'm pretty sure that most of you use it and use it a lot, right? Since we live in an interlingual environment, so that's no news. But I guess that most of us use this machine translation just without thinking twice, without even thinking of the quality of the result. Those who have been in the industry of translation are a little bit scared of losing a possibility to lose their jobs, and yeah, those who still remember how to use a pencil and paper, yeah, next slide here with the arrow keys. No.
Is it okay, or is
I think
it
is. I think it is. Yeah, well, I don't mind. Yeah. So people like me who've been in the industry for decades still remember how to use a pencil and paper, and we were very happy when first computer-aided translation tools were introduced. Since they provided great instruments and they were really helpful, and they provided an user-friendly environment for the translator, for the human translator, and lots of really cool tools. But my students actually are reluctant to use them. They tend to rely on machine translation. Yeah, now these computer-aided tools, like there's a great deal of them. Some of them are paid, some of them are free access, some of them are online, some of them have to be downloaded and installed. Sometimes you have to pay for the license, and if you refuse to pay for the license, then we have a limited version. For an amateur, it works. For a professional, you normally pay, and that's how it worked. Then I think I will list the key tools with an illustration on probably the most famous translation tool as the Trados. I hope that at least some of you have ever tried it, at least my colleagues. Just a couple of words, just because it contains all the necessary tools, and it's probably the most sophisticated computer-aided tool ever. Just because they managed to get contracts with the European Union, and they raised massive funds, and they invested a lot, and made a really sophisticated software package. Yeah, but most of their competitors contain standard tools. That's the so-called translation memory. That's a TM, yeah, translation memory. And then the workbench, which is your environment where you work. This portion, right, where you actually work. Then the term base, and this is still important today. Then auto-suggest, I guess you probably have this auto-suggest in your smartphones, and some of you probably use it. You hate it, right? Me too, because it normally it makes you nervous, and sometimes it makes you embarrassed, right? So auto-suggest, it's still the is not a very important function. Then spell checkers are critical, I believe, especially when you work with, even when you work with a native language, spell checker is a handy tool. And then simultaneously with these computer-aided translation tools, machine translation was introduced, and I hope that younger people probably don't remember this Google Translate 20 years ago. Yeah, it looked ridiculous, sometimes funny, and we used to make jokes of it, but not anymore. Now it works like a really great tool, and I guess that most of you use it a lot. Then what's specific about SDL Trados, it's that they've got this navigation pane, which is really useful when you deal with long text with massive amount of work, and when you have to navigate through hundreds of pages. Good. Now, some of these are still important, like, for example, term bases, which help us to use the uniform term for the same uniform equivalent for the same term. Whereas in machine translation, they might be a mixture. Sometimes they use one term, and in the next sentence, the same term might be translated into a completely different equivalent, which means that you still have to revise it. You still have to check it for equivalency and for equivalence, and for other things, other errors. Now let's get to the machine translation, which I said, which was 20 years ago was kind of really poor, yielded poor result. And the first machines, first translating machines were the so-called rule-based machines, machine translation, rule-based. Those who studied linguistics probably remember these translation models, like people try to model the translation process just to give ideas, what steps to follow, just like a precise instruction to assist you. But these instructions actually stayed only in textbooks and have never been used actually. Then this rule-based translation, RBTM, was replaced by statistical machine translation, which is based on massive corpuses of text. So I'm sorry to tell you, but that didn't work either. Right, so these needed massive amount of data, and then software developers or engineers try to develop like specific, very sophisticated algorithms to match different lexical units from different languages. And that worked better probably, but still not perfect. And therefore, the statistical machine translation was replaced by hybrid machine translation, which combined both rule-based and statistical. Right, but it is not until the neural machine translation was introduced that it really took off. And that the machine translation became able to compete with this software. So that's why my students just don't like it and deem it as a like, completely outdated thing. Now, CAT developers attempt to introduce this machine translation, integrate the machines, this neural machine translation into their software. Sometimes they even charge money for free tools like Google Translate or DeepL.com, which is ridiculous. And yeah, but they still do attempt to collect the profits. And now a couple of words. A couple of words about specific mistakes, specific errors that occur when you rely upon machine translation, and then we'll discuss how what actual effect might this have, the whole thing have on the industry itself and on businesses who pay money for translations or who are reluctant to pay money for translations. Right. I included some samples. Basically, that I researched different discourses, starting from the letters, publicistic articles, and to specific like legal documents, legal acts, contracts, and memorandums, like different discourses. But I just included very simple examples here, just for the audience. And for those who understand Lithuanian, I think it is going to be obvious. For those who don't, I try to submit a so-called back translation, which is when you translate it to the original language. The translated text is translated to the original language. So technically, the first one and the last one should coincide. I mean, if the machine works perfectly, then it has to yield the same example, the same result as the initial sentence. Now, as you see, they slightly differ. I identified this error as an error in text cohesion, just because the machine failed to identify this pronoun it. It supported it in the sentence is the idea, right? But in the translation, this it is somehow lost. And even the gender is mixed up, right? Since the gender is absent, in English, then the gender is mixed up here. You've got masculine versus feminine. All right, now DeepL, and this is by neural machine translations supplied by SD Altratos. Now DeepL yields a better result actually, but still, when you back translate it, again, it is kind of weird, and it mixes the word order, so brings the supporters to the back of the sentence, and then it slightly distorts the meaning. then it becomes uncertain who supports us, the ideas or the pipelines or the algae, right? So it becomes a slightly ambiguous. But that's a minor issue which can be dealt with. Right. Sometimes errors occur in sentence grammar. Like here, a restrictive sentence was translated into a non-restrictive, right? So instead of that form the plan form, we've got which form the plan form. It's not a big deal, but it's still an inaccuracy. Then this over vertical sheets, this phrase again is translated into different ways. Gives the different result. And then again, if you back translate it, it over changes into N. So also some issues and some inaccuracies in equivalency, in word equivalency.
Put it down because we don't see a back translation.
I didn't know that. Yeah. Okay, diffuse scatter, that's the same, more or less the same, right? Over vertical sheets in the vertical sheets is already a different concept, right? So is an obvious inaccuracy, right? So that's not accurate. Okay, let's move to the next example, which produces an error in modality. Like in the original, you've got is unable to support. In the translation, you've got does not support. Again, not a big deal, probably not a serious issue, but still an issue, right? An issue that, strictly speaking, has to be taken care of. Good. And I guess this one is the last, which is an error produced because of the absence of equivalent, of the Lithuanian equivalent. Like this bubble cannot be translated word by word into Lithuanian. And therefore, look, this bubble is just turned into a verb, and then this verb sounds ridiculous in Lithuanian. Yes, when you back translate it, then bubble back up. Yeah, bubble. Yeah, that's probably okay. But this one is probably only for Lithuanian speakers. So in this non-equivalency typically occurs in legal documents where the systems differ and a specific equivalent is simply absent, and then the machine simply isn't able to produce a good result. So what I was trying to say there is that you still cannot rely 100% on machine translation. It's good, it's really good, but it's not ideal. Sometimes it works. I mean, for specific purposes, like in everyday situation, it works perfectly and it's okay, and people can understand you. But when you need accuracy, for example, in the same legal discourse, when your document is likely to go to courts, to be read by courts, then it becomes critical. Then accuracy becomes critical. So sometimes this accuracy actually matters, and therefore, human translators are still likely to retain their jobs. Just fewer of us, right? Just the scope of work gets minuscule, like very, very small. and which means that the major portion of us will be made redundant, right? And another risk for the translator is that businesses are reluctant to pay money for pressing the button on the machine. I mean, when you hire a translator and you see that they just press one button, you think, yeah, Jesus Christ, and you charge with 15 euros for that? No way. Yeah. So in terms of pay and in terms of the scope of workload, we're in trouble. But actually, there's still something to do. There's still a role for us to play, for the human translator to play. And I'm not sure about grammar and syntax. Probably these will be dealt with the machine easily in future. Equivalency, again, for the equivalency, probably software developers might use these big corpuses, corpora. With text cohesion, it is. It might work as well, I think. Now, finally, what it means for businesses and the industry. I already mentioned that for the industry, it's kind of it means a certain risk of being made redundant because machines are fast, accurate, and cheap. Whereas human translator is slow. Well, this speed has been formerly dealt by employing crowdsourcing, like employing many people on a tiny block of text. But it's still slow, although more accurate than the machine, still more accurate. But I believe that businesses will probably try to save costs and will probably choose to rely upon machines. Now another problem might arise for the machine itself. Okay, I've forgotten to mention what the neural machine translation is. Like, neural machine translation is reminds a network of PCs which are connected to each other like neurons in your brain, which enables the machine to learn itself. So in other words, the machine learns itself, and what you have to do is just to train it. And the problem here is especially it applies to these low resource languages like Lithuanian, right? Or I don't know other languages where very few people speak, then the machine misses the chance of, or the machine's opportunity to learn is limited. And therefore, it still works better with big languages like French, English, German, Spanish, Mandarin Chinese. I'm not sure about Mandarin Chinese, by the way, because they have different dialects. Yeah, so that's one drawback, that's one problem for the machine itself, because when you have fewer translators, you have fewer chances to learn. And there might be difficulties in doing research because the number of people interested in the research and in the field is getting smaller, right? And people who are from outside are reluctant to respond to our questionnaires sent via online or via Google Forms, right? But what do you normally do when you receive this? Please submit this Google form, like it's very important for us. And you think, Jesus, like how long does it take? 20 minutes? No way, right? So that might cause certain difficulties for researchers as well. Which means that eventually it can kind of backfire. especially with the low resource languages. Finally, the final conclusion here would be that since most of my colleagues are going to lose their jobs, and since businesses get a chance to save money, we will probably have to introduce, like, these new technologies are about to introduce new social models. In other words, we will have to find new jobs. Right? I don't know. I think it's on the opposite. It's optimistic. Technological development always induces changes in social modeling. So I believe that changes in our social model are about to appear in the closest future. And thanks for listening.
Thank you, Dario. It was really amazing. One of my students, by the way, made bachelor when she compared the human translation from Norwegian to English and machine translation. What was interesting with terminology, that humans, they tend to use terms consistently, but machine used very inconsistently.
That's the problem, and that's why I said that you still need this. Let me get back. No, this term base. Term basis, and another tool which is in CAT is the so-called concordance, where you can check the previously made translations.
I was explained by IT specialists that machine focuses on a paragraph. It translates one paragraph, then translates another, and does not keep the memory.
Yeah, so it's got something to do with cohesion, right? So it forgets what was yesterday.
And you know, in terminology, it's crucial that the same concept is denoted by the same term. And that was like conclusion in my students' work, that humans are much better in keeping that consistency yet than machine. But
I actually
try
to do the same. I actually try to ask my students to submit this. Like, I wanted to compare how student translation, machine translation, but I failed just because students would use the machine.
Yes. Thank you, dear students, for coming. I hope maybe you got some interesting ideas. So thank you for being. Yes, thank you. Goodbye.
Thank you.
Goodbye. Goodbye. And thank you, dear Alexander. I'm ending the recording.